All right, you can probably just read this, but sometimes when we're talking about energy, they like to talk about conservative versus non-conservative forces, all right? And it tends to me to get really super complicated and confusing, but it's actually really not, so just kind of be simple about it, okay? So a conservative force would be one that is what they call path independent, okay? It doesn't matter how you get there, the end result to the energy is the same, okay? And mainly the one that we'll talking about is gravity, okay? Kind of how we talked about the other day, right? Like it doesn't matter if I lift this up to this height, okay? Or I roll it up to this height, okay? Or if I take a curvy path up to this height, or if I go like this up to this height, it doesn't matter, okay? That work done by the gravity force, okay, is always the same thing, all right? Because it doesn't matter. The displacement in the same direction of it is still the same no matter how you got there, okay, the displacement, all right? Sometimes they like to throw in a multiple choice question like you'll see kind of on the bottom. They might sort of talk about it. But the main thing is if it's a conservative force, it's not dependent on the path taken, okay? And it's reversible, right? So like if I do this work and give this energy, if it comes back down here, it transfers out that energy, right? A non-conservative force, mainly we'll be talking about friction, okay? There could be other stuff, but mainly it'll be friction because it does depend on the path taken, right? So like if I lift that ball straight up, right, it's going to waste a certain amount of energy like air resistance, whatever. But if I roll that ball up this curvy path to get to the same height, that's been more time and more distance rubbing against the ground, which is continuously wasting energy, okay? So friction is a non-conservative or path-dependent force, right, because it is going to be dependent on how long it rubs against the ground, okay, versus like taking a straight path would waste less energy, okay? It says it adds or removes energy from the system, okay, with friction always removing, and it's not recoverable, right? So that's like when we're putting something into that E-therm or a dissipated category, something that's a non-conservative force is not reversible back. Like I can't then just roll it back down this same path and then end up getting the energy back. Okay, once it goes into friction with a non-conservative force, it's wasted and gone. Okay, all right, so here's just a little example, right? I showed you that the gravitational potential energy can kind of go back and forth, okay, if there's not any friction. But when there's friction, it's just going to constantly waste out that energy, waste more, waste more, waste more until it's kind of over and it's not reversible. Okay, and you can do the multiple choice.